Hello, good afternoon. Today we're going to be doing linear functions day 3 for pre-calculus. We're going to cover parallel and perpendicular lines, how to write an interval notation, how to interpret and calculate composite functions, and how to use your grapher to find intersecting lines to solve a problem. So grab your grapher and let's go. Roman numeral 1. We're going to start with interval notation. Interval notation is a lot more flexible than inequality notation, and we need that flexibility in pre-calculus in order to express domains and ranges of what we're working with. So first one is, let's say x is greater than or equal to 2. That would be an inequality notation. To draw this out, sometimes the drawing helps figure out how you're going to write it. You have 2 as a critical point, and in interval notation, you would say x is equal to 2, and it's greater than 2, so you'd have an arrow going to the right. Okay, in interval notation, when you have an included point like that, it gets a bracket. And in fact, we draw it, if you're asked to draw in interval notation, the 2 would actually get a bracket on the graph instead of a dot. The arrow would be the same. Now, notation-wise, our values are starting with 2, including 2. So they get a bracket because it includes the 2, and it goes to the right infinitely, so it goes to positive infinity. Infinity always gets a parenthesis because you can't measure infinity. It never ends. All right, let's do another example. X is greater than equal to 0 and less than or equal to 6. Okay, so again, if I were to draw this using inequality notation, you would have a dot on the 0, a dot on the 6, and everything in between would be part of the function. In interval notation, the 0 and the 6 are both inclusive or closed boundaries, so it would get a bracket and a line in between. So in interval notation, it would be from 0 to 6 inclusive. So that's another term you need to know. Bracket means inclusive boundary. In other words, the 6 is part of the solution set. That's an inclusive boundary. It's also sometimes called a closed boundary. So inclusive boundary or closed boundary. Okay, number 3. X is less than -1. And so in inequality notation, you would have an open point on the -1 and the arrow would go to the left. In interval notation, when you have an open boundary point like that, it gets a parentheses pointing in the direction of where the arrow is, in this case to the left. So you would write this as low bound, negative infinity, because it's all the way to the left, up to -1, and then it would get a parentheses because it is not included in the solution set. So parentheses means what we call an exclusive boundary, because it is excluded from the solution set. It's still a boundary, but it's not part of the solution set. It's also called an open boundary because you can get infinitely close, but not right on it. All right, last one of these. We're going to do x is less than 0 or x is greater than or equal to 2. By the way, this is an and, this is an or. This expression you can write x less than equal to 0 and x greater than equal to 0 and x less than or equal to 6. So that has 2 different ways to write it, and or doesn't, just one. So again, if you were using inequality notation, 0, it would be less than but not equal to, so it would have an arrow going to the left of 0. And then at 2, it would be inclusive, so filled in dot, arrow going to the right. That's your OR graph. In interval notation, 0 is not included in the solution set, so it would get a parentheses facing left with the arrow. 2 is included in the solution set, it would get a bracket facing to the right. So you would write this piece first. You'd say negative infinity up to 0 exclusive, because it doesn't include 0. And this is where you're going to need to use a union symbol. A union symbol kind of looks like a capital U, but it doesn't have a stem on it. It's actually a Greek symbol. So the in union with, and then you do the right side, 2 inclusive, and this goes infinitely to the right, so up to positive infinity. And again, the infinities always get the parentheses. All right, that's interval notation. And you'll get to really like it after a while because it is so much faster and easier than trying to do inequality notation. Okay, Roman numeral 2. Parallel lines. Parallel lines. Okay, parallel lines have the same slope. Sometimes you'll see it written m sub 1, slope of the first one, is equal to m sub 2, slope of the second one. An example of parallel lines would be y equals 3x plus 2 and y equals 3x plus 1. Both of their slopes are 3's, so they are parallel. Now, if we called this one y sub 1 and this one y sub 2, to write that they are parallel, we would say y sub 1, and then parallel looks like two oversized L's put together. Y sub 1 is parallel to y sub 2. That says they are parallel. Now, as far as graphically speaking, draw yourself a little pair of axes. This one crosses the y-axis at 2 and has a slope of 3. So 1, 2, 3 over 1. This one has a slope of 3 and it crosses at 1. Okay, so what you'll see, 1, 2, 3, 1. There we go. Is that they never intersect, they never cross. So if you have two lines that are parallel and you're looking for a solution, there would be no solution for them because they have no intersection. Okay, that's parallel lines. Roman numeral 3. Perpendicular lines. Perpendicular lines. Okay, so perpendicular lines have slopes that are what we call negative reciprocals. The slopes are negative reciprocals. This means that the slope of 1, m sub 1, is equal to negative 1 over the slope of the second one. Now, when you're calculating slopes that are perpendicular, it's pretty simple. If you have a slope of 2/3 for 1, then the slope of the second one, you're going to flip that, so 3/2, and multiply by a negative 1, which is negative 3/2. So not only is it flipped, it's negative. If your slope is a whole number like 4, then the perpendicular slope would be flip it, 1 over 4 times a negative 1, which is negative 1/4. You'll notice that 1 is usually positive and 1 is usually negative. So that's the one way you can kind of look out for it. Generally, if one slope is a whole number, the other one's going to be a fraction because you're going to flip it. So how in the world do you figure out if they are perpendicular? Okay, so let me give you a pair of lines. Y equals 4x minus 1, y equals negative 1/4 x minus 1. So these are their slopes, and you can tell that if one is 4, when you flip it and multiply by -1, the other one has to be -1/4. The sign for perpendicular, this is y1 and y2, is an upside down capital T. That says line y sub 1 is perpendicular to line y sub 2. Now there is actually a test for perpendicular slopes. I don't use it very often, but it'll work. If the first slope times the second slope is a -1, therefore, remember the 3 dots, therefore, line 1 is perpendicular to line 2. So if you multiply the slopes and you get a -1, you're in luck. So let's try this out. We've got 4/1 times -1/4. That would be -4/4 or a -1. So sure enough, those two slopes are perpendicular. Okay, graphically speaking, if I were to graph those two, let's see, they both cross at -1 on the y-axis. One of them has a slope of 4, so I can count up 1, 2, 3, 4, and over 1. These are just a rough graph. That's my y sub 1. The other one crosses at -1, but the slope is -1/4. So 1 down, 1, 2, 3, 4 to the right. And as you can see, those lines are definitely perpendicular. So in order to decide if they're perpendicular, you need to know the slopes, which means you probably need to put them into slope-intercept form, solve for y, and then compare the slopes from there. All right, so we're going to move on to function notation and composites. We did a little bit with function notation on the last set of notes. So now we're going to talk about composites. So this is Roman numeral 4. Function notation and composites. Function notation and composites. Okay, so just a quick review. Let's say we've got f of x equals 3x plus 1, and we've got g of x equals x minus 1. Okay, remember that the letter in front of the x, the left side of the equation, is this part here. This is strictly notation. It's a description. So this describes what's going on. The right-hand side is the actual math calculation. So on this first one, the f is the name of the function. It's function f. Here, the name of the function is function g. When we say f of 2, what we're saying is use function called f and replace x with 2. So it's giving you directions on what to do. So you're going to find function f, replace x with a 2. That gives us 3 times 2 plus 1, which is 7. So this tells you what you need to do and how to calculate it. If I do, for example, g of 3, I'm going to use the function called g. I'm going to replace x with 3. 3 minus 1 is 2. Okay, so that's your basic how you calculate. So let's get into composite notation. Composite notation, I'm going to write composite, is where you substitute one function into another and simplify. That is a composite. So an example of a composite, using our ones up here, would be f of g of x. So the inside one says we're going to leave the x in g. The composite part is that we're going to take this whole expression and we're going to replace x in f with g of x. So what does that look like? Well, remember f of x is 3x plus 1. So we're going to have 3, and instead of x, I'm going to put this whole function in it. X minus 1, and then plus 1. So it's this function with x replaced. And then usually you simplify. So distribute 3x minus 3 plus 1 is 3x minus 2. So f of g of x is 3x minus 2 when you're done simplifying. Let's go the other way. G of f of x. We're going to replace all the x's in g with the f function. Okay, so looking up at g, g is x minus 1. So instead of x, I'm going to put 3x plus 1 and then the minus 1, which of course is 3x. So g of f of x is equal to 3x when you simplify it. What happens if you replace something with a number? Okay, let's do f of g of 2. So this gives us two things we need to do. We need to substitute 2 into g. That will get us a number. And then we're going to take that number and substitute it into f. Okay, so let's first find g of 2. So go to g function and replace x with 2. So 2 minus 1 equals 1. All right, so that is what we're now going to substitute into f. So f of 1 equals, replace the x with a 1, 3 times 1 plus 1. 3 plus 1 is 4. So your answer would be f of g of 2 equals 4. You'll notice that if there's an x, you should have x in your answer. If there's a number, you should have a numeric answer. You can also put, this is the last one, and we're going to go on, you can put a function into itself, which is always kind of fun. F of x. So we're going to take every x in f and replace it with itself. So let's do that. So we have a 3x. So instead of x, I'm going to put in 3x plus 1 and then plus 1. It's substituted into itself. Simplify, you get 9x plus 3 plus 1, which is 9x plus 4. So f of x is 9x plus 4. So that's composites and function notation. All right, number 5. We're going to do a grapher question. So we're going to use our grapher. And we're going to learn how to intersect lines. And I'm actually going to use an example from the book. I believe it's one that you're assigned on page 37. It's number 46. All right, so the question reads, Mary Ellen plans to invest $18,000. Okay, that's important. So $18,000, that's what she's going to invest. Putting part of the money, X, so X dollars, into a savings account that pays 5% annually. 5% annually. And the rest into an account that pays 8%. So the rest of the money, which would be 18,000 minus whatever we put in the first one, that rest of the money is going to go into the 8% annual account. Okay, so let's go through the questions. Question 1, what are the possible values of X in this situation? What could X be? Well, she could choose to invest nothing into X. She could choose to invest all in X. She has 18,000. So your boundaries are going to be between 0 and $18,000 inclusive, because it can be 0 or it can be $18,000. Okay, question B. If Mary invests X dollars at 5%, which is already in the question, write an equation that describes the total interest received from both accounts at the end of 1 year. Now, the fact that this is at the end of 1 year means it's only going to calculate the 5% and the 8% one time. That lets us use a very simple equation. They told us to use I for interest. So interest equals 5% of what she invested at X, so 0.05 times X, plus in the 8% account, 0.08, it's whatever's left over from the 18,000, so 18,000 minus X. And that would be how much interest she would get. So I is the interest in dollars. Okay, C. Graph and trace to estimate how much Mary Ellen invested at 5% if she earned 1,020 in total interest at the end of the first year. So if her interest is 1,020, what is X? How much did she invest at X dollars? Okay, so this is where we're going to use our grapher. Now, if you have your grapher on from a plot, you need to turn those off. So second stat plot, I have to push enter and turn my plot off. You don't want any plots messing with your linear equations. Okay, so clear those out. That was in stat plot again. There we go. So now we're going to go into the y equals menu. We're going to clear that out. And I need to put in my equation that calculates interest. So 0.05x plus 0.08 times, and then we use your parentheses, 18,000 minus x close. My calculator, you can actually delete that star, that time symbol, and it will calculate it just fine. You may or may not. So this is our equation for interest, and we need to set a window, a decent window. So our x values, the amount that she invested at 5%, starts at 0, so that's our x minimum, and she could go all the way up to 18,000. 1, 2, 3. There we go. X scale, I would probably go by 500s just to keep it from getting messy. Okay, y minimum. Y is, we're wanting to figure out if y is 1,020. So I need to bracket that. So I'm going to go 0 to, and I need to get above that, so maybe 2,500 to be sure I can see it. And I'm going to go by hundreds, I think. So that looks like a decent window to show me what I'm going to be doing. So hit trace. So this curve goes downward, which actually makes sense because the x value is only calculated at 5%, which is a lot less than 8%. So the more she invests at 5%, the less she invests at 8, she actually makes less money. So it makes sense that the curve is going down. Now we want to know if y is 1,020. If the interest is 1,020, what would be the amount that she invested at 5%? What's the x? So we're going to do intersecting lines. So go back to y equals, push your down arrow to y sub 2. We want y just to be the number 1,020. Because we want to know if y equals, if interest equals 1,020. So this is your y value. Then what's x? And let's trace that. If you can't see where the two lines cross, you need to adjust your window so you get a clearer picture. Okay, so we're going to really quick do a grapher sketch to show our work. And we've got one line that's clearly horizontal. We have another one that's coming down. And our window was 0 to 18,000 for X and 0 to 2,500 for the Y. There's our graph or sketch. That's how we show our work. We want to know that point right there. Okay, so this is how you do it on a grapher. All your calculation buttons for your graph is under Calculate. So second, find Calculate, toggle down to Intersect, push Enter. Now it's going to say first curve, and it's going to tell you up top which curve you're on. So I'm in my Y1 curve. And so what they want to know is first curve question mark, where is to the left of where you see it cross? I'm just going to put it there, enter. Second curve. Now on the second curve, you have to go to the right of where you see it cross. So the first curve you go left, the second curve you go right. Enter. Best guess, put it right where you think they cross each other, like right there, push enter. And if you look at the bottom, it tells you that the intersection, it says, is X equals 14,000 and Y equals 1,020, which is what we wanted. This is our X, this is our Y. Remember that X is what's invested at 5%, Y is the interest earned. So the answer to the question, if Y is $1,020, what is X? X equals $14,000 at 5% interest. That's the answer, that's the work. Okay, D. D says use your grapher to generate a table of values for I to find out how much Mary Ellen should invest at 5% to earn. Okay, so they want to know, she wants to earn $1,185. And we want to know what is X. And this time we're going to use a table function. Okay. First thing I want to tell you about tables. Tables are not a great way to find an intersection point. Tables are pretty inexact. So if they're asking you to find it using a table, it's not going to be a very precise answer. Okay, so let's do a table. So first thing you need to do, you have a table function here, second table. If you just go straight into table, which is right there, it's going to take your equation for y sub 1, which is your interest calculation, and then y sub 2 was the amount that we inputted here. But we're no longer interested in $1,020. We're more interested in $1,185, and we want to know what's going to make that happen. If all you do is press table, these values are not calculated from each other. They're calculated only from the equation separately. Well, we want to know, using our equation, what will make interest $11,085. And you can tell this is wrong because the y's aren't changing. Okay, so let's go into y equals and let's eliminate. So clear that out. Now go back to table. You should only have values for y sub 1. These are your x's, these are your y's. Now obviously we're at 1,440. We're looking for 1,185. These are not changing very fast. We needed to get down to 1,185. So yes, we could actually toggle, and it will set in x equals 11, 12, 13, 14, 15, and it will substitute the x's in order and give you the y that results. This is really slow though. So let me show you a better way to do this. Go to Format, so second Format. This is your, oh sorry, not Format, Table Set, excuse me. Second table set, there we go. Independent variable is x, dependent is y. We're going to say ask. Ask me what x I want to use, and then auto-calculate the y. So then go back to your table. Now your x is blank. So here's where you're going to try to put some values in. Let's say x is 6,000. We invest $6,000. What would be the interest? That's $1,260. We need it to be a lower interest rate, so we need more x. So 8 1,000, 1,200, we're getting warmer, 9,000, 1170. Okay, so I went down too far. It's close to 9,000. I would probably try 8,500. 1185 on the nose. So basically what you have to do is input values until you get the one you want. Now you know why it's not a great method to use a table that way. What are tables used for? Tables are great if you just need to calculate a bunch of values from an equation. Then you don't have to do it by hand. So this is our work for the table. We did 6,000, 8,000, 9,000, 8,500. We got 1,260, 1,200, 1,170, and the winner 1,185. So X equals $8,500 at 5%. And that is your work for the table. Okay, so I've shown you how to do this using intersecting lines. I've shown you how to do this using a table. Remember that the table function is above graph. That puts you in the table. Table set is above window. Why they put it above window, I don't know. And if you do want to do like an automated list, you can tell it, I want you to go by 50 intervals of 50, and then you can go to auto. And you can tell it where to start. Let's say I wanted to start at $6,000. I want to go up by 50s, and I want it to automatically generate. So now when I go into table, it starts at 6,000, it goes 6,050, 6,100, 6,150. It goes up by the increments I chose. So it can actually calculate it that way, but again, it's not a very exact way to do things. All right, that concludes our notes. I hope that was helpful. Have a good afternoon.